The salty air hung thick and heavy over the deck of the Sea Serpent. After months of chasing cryptic maps and dodging naval patrols, the moment had finally arrived. 5 weather-beaten pirates stood over a massive iron-bound chest, its lid gleaming with water droplets from the morning's mist. Their names, whispered with a mix of fear and respect across the 7 seas, were Amaro, Bart, Charlotte, Daniel, and Eliza. Amaro, as the captain and the most senior pirate, held the key. With a loud creak, he turned the lock, revealing a shimmering mountain of 100 gold coins. The sight was honestly enough to make any pirate's heart pound, but this was no simple treasure to be divided. These pirates lived by a strict, if brutal, code. This wasn't just about splitting the gold, it was a test of wits, a dangerous game where survival was the ultimate prize. The 5 pirates eyed each other, their initial joy replaced by a tense, calculating silence. Each one knew the rules. Each one knew that a single misstep in the coming negotiation could be their last. The 100 coins weren't just wealth, they were a life-or-death puzzle waiting to be solved, and the first move belonged to Amaro, the captain. The challenge was made even more complex by the pirates' own natures. Every single one of them was perfectly logical, ruthlessly self-interested, and above all, driven by a powerful desire to survive. They weren't prone to emotional outbursts or sentimental friendships, especially not when gold was on the line. Their decisions would be cold, hard calculations based on 2 simple priorities. First, stay alive, and second, get as much gold as possible. This predictable, logical nature was the key to the entire puzzle. The pirate code governing the treasure was simple in its wording, but complex in its implications. The most senior pirate, in this case Amaro, would be the first to propose a division of the 100 gold coins. He could suggest any split he wanted, from keeping it all for himself to giving it all away. Once the proposal was made, every pirate, including the proposer, would cast a vote, aye or nay. This was where the danger lay. The rules for the vote were precise and unforgiving. If the proposal received a tie in the votes, or if it received more aye votes than nay votes, the proposal would be accepted. However, if the proposal received more nay votes than aye votes, the consequences were dire. The pirate who made the proposal would be deemed unfit, a failure in the eyes of the crew. According to the code, they would be unceremoniously thrown overboard into the shark-infested waters. There would be no second chances, no appeals. After the unfortunate pirate was disposed of, the next most senior pirate in line would take their place. The process would repeat until a proposal was finally accepted. This voting system created a fascinating dynamic. The key was the threshold for success. A tie was good enough. For Amaro's 5 pirate crew, this meant he only needed his own vote plus 2 others to secure a majority. He didn't need to please everyone. He just needed to convince 2 other pirates that his deal was better for them than the alternative. And what was the alternative? The alternative was Amaro being thrown overboard and the game continuing with 1 fewer pirate. To solve this complex puzzle, the smartest pirate wouldn't start by thinking about the 5 pirate scenario. That's too complicated. Instead, they would simplify the problem and work backward from the end. Imagine a scenario where things have gone horribly wrong for Amaro, Bart, and Charlotte. They have all been thrown overboard and only 2 pirates remain, the senior pirate Daniel and the junior pirate Eliza. There are still 100 gold coins to be divided. Now it is Daniel's turn to make a proposal. In this 2-pirate world, Daniel holds all the power. He needs a tie or a majority to win. With only 2 pirates, his own vote of aye guarantees at least a tie, 1 aye from him, and at most 1 nay from Eliza. Because a tie means the proposal passes, his plan is unstoppable. Knowing this and being a greedy pirate, what would Daniel propose? He would propose to keep all 100 coins for himself and give 0 coins to Eliza. His proposal would be, 100 for me, 0 for you. He votes aye, Eliza votes nay, but the 1-1 tie means the proposal is accepted. Daniel gets all the gold and Eliza gets nothing. This outcome is certain because all the pirates are logical. Eliza knows that Daniel will do this and Daniel knows that he can get away with it. This is the foundation of our entire solution. Now let's add 1 more pirate back into the mix. We need to understand what happens when 3 pirates are left: Charlotte, Daniel, and Eliza. It is now Charlotte's turn to propose a division. Charlotte, being a smart pirate, thinks about what her crewmates want. She knows what will happen if her proposal fails. If she is thrown overboard, the game becomes the 2-pirate scenario we just solved. She looks at Daniel. If her plan fails, Daniel gets 100 gold. It's impossible for Charlotte to offer him more than that, so she won't even try to win his vote. But Eliza is a different story. In the next round, if Charlotte is gone, Eliza gets absolutely nothing. 0 coins. Therefore, any offer is better than nothing for Eliza. To secure Eliza's vote, Charlotte only needs to offer her a tiny bit more than 0. Being a greedy pirate, she will offer her the smallest possible amount. Just 1 gold coin. So Charlotte's proposal is 99 coins for me, 0 for Daniel, and 1 for Eliza. Charlotte votes aye, Daniel votes nay, but Eliza, choosing 1 coin over 0, logically votes aye. Charlotte's proposal passes. Now let's take another step back and reintroduce Bart. We now have 4 pirates. It is Bart's turn to propose a division of the 100 coins. Bart thinks ahead. If his proposal fails and he is thrown overboard, the game reverts to the 3-pirate scenario. In that scenario, Charlotte gets 99 coins, Daniel gets 0, and Eliza gets 1. Bart needs to convince one of these pirates to vote for his plan. He can't win Charlotte's vote because she's set to get 99 coins. But Daniel is the key. Daniel knows that if Bart is thrown overboard, Charlotte's proposal will give him nothing. Therefore, Bart can secure Daniel's vote by offering him just 1 gold coin. So, Bart's proposal is 99 coins for me, 0 for Charlotte, 1 for Daniel, and 0 for Eliza. The vote is a 2-2 tie. Bart's proposal passes. We have finally arrived back at the beginning, on the deck of the Sea Serpent with all 5 pirates. It is Amaro's turn. He must devise a plan to divide the 100 coins among himself, Bart, Charlotte, Daniel, and Eliza. Just like the pirates before him, Amaro must think about what will happen if his proposal fails. If he is thrown overboard, the treasure would be split as follows. Bart gets 99 coins, Charlotte gets 0, Daniel gets 1, and Eliza gets 0. Amaro now has all the information he needs to secure his survival and maximize his gold. He knows exactly who to bribe and for how much. He needs 2 votes from his 4 crewmates. He can't win Bart's vote because Bart is poised to get 99 coins if Amaro fails. The pirates who stand to get nothing in the next round are the most vulnerable and the easiest to bribe. Amaro looks at Charlotte and Eliza. If he fails, they both get 0 coins. He can win each of their votes by offering them just 1 coin each. Therefore, the smartest, safest proposal Amaro can make is 98 coins for Amaro, 0 for Bart, 1 for Charlotte, 0 for Daniel, and 1 for Eliza. Let's count the votes. Amaro votes aye for survival, Bart votes nay, Charlotte, choosing 1 coin over 0, votes aye, Daniel votes nay, Eliza, choosing 1 coin over 0, votes aye. The final tally is 3 ayes to 2 nays. Amaro survives and keeps a handsome 98 coins. This is the power of pure cold logic. The puzzle isn't about fairness, it's about understanding incentives and predicting behavior. It teaches us that by thinking several steps ahead and working backward from the end, we can find optimal solutions to even the most cutthroat problems.